Hey guys, we are going to be continuing chapter 6 in our exploration of polynomial functions. Um, I will be back next week, so I hope to see everyone in class. But for today, we're going to finish up the chapter. So we're starting with 6.2.2, I believe. And the first thing it talks about is most of this is just that relationship between or zeros and the function. So you have a function. If you solve it, you get the zeros. They're also the x-intercepts. They're also the solutions. All of these mean the same thing. So if I have something simple like a quadratic, and I have the zeros are 2 and 4, so that would be x would equal 2 and x would equal 4. Well, then the factors would be x minus 2 equals 0 and x minus 4 equals 0. And so if I put those together in a quadratic, it would be x minus 2, x minus 4, and then the function would be x squared minus 6x plus 8. Okay, so we have these are the zeros, the x-intercepts, the solutions. These are the factors, and this is the function. Okay, so this same relationship of these same terms we're going to find with polynomials. So for example, number 2 says, write the simplest polynomial function with the given zeros, and the zeros are -2, 2, and 3. So that would mean that x would be -2, x would be 2, and x would be 3. So the factors would be x plus 2, x minus 2, and x minus 3, because I have to move these over to the other side. And when I do, they become the opposite. So to find the function, I would then need to multiply these together. The first two, remember, if it's a positive and a negative, that's going to cancel out the middle term. So this is going to be x squared minus 4, because it would be x squared plus 2x minus 2x, but those would always cancel. So that's an easy way to do that one. And then minus 3, I'm going to FOIL this again. X squared, no, that was a lie. X to the third minus 3x squared minus 4x plus 12. So then this would be my function. And the answer. It also always asks for it to be the simplest function, because you could like multiply this whole thing by 3 and it would still have the same x-intercepts. It would just have the amplitude would be different. Amplitude meaning like how much it goes up and down, but the x-intercepts would still be the same. So there is that. Then there's a little bit more factoring, which we've done a ton of. And then it talks a little bit about complex solutions and complex roots. So like number 9 says, write the simplest function with the zeros 2i square root of 2 and 2. And we've talked about this, I think, a little bit, but maybe not too much. Complex solutions always come in pairs, kind of like square root. So remember, because the square root of 2 is a positive and a negative number, so these come in pairs. So I also have -2i and negative square root of 2. Even though if those aren't given, you have to just know that those always travel in pairs as a positive and a negative. So this would be x plus 2i, x minus 2i, x plus square root of 2, x minus square root of 2, and x minus 2. And just to make sure, I got the minus 2i here and the plus 2i here, because I set them equal to 0. So x equals 2i is x minus 2i equals 0. Make sure we understand that relationship. And then I'm going to multiply these, and because this is a positive and a negative, I know that that middle term is going to cancel. So this would be x squared, and then 2i and -2i is, so I have 2i times -2i, which is -4i squared, but I squared is -1, so -4 times -1 is +4, plus 4, x squared Remember, the middle terms are going to cancel. Square root of 2 times the negative square root of 2 is negative 2. And x minus 2. So then I need to keep multiplying. I'm going to do these two together first. So x to the 4th minus 2x squared plus 4x squared minus 8 x to the 4th plus 2x minus 8 x minus 2. Foil this. Why don't y'all pause real quick? Make sure you know how I got this so far. So push pause. Make sure if you have any questions, ask each other, and then I want you to do this last bit of multiplication. It's the hashtag double distrib. You're going to double distribute the x and the negative 2. So do that, and then come back and see how you did. Okay? So pause, come back and check. Okay, here we go. So it's going to be x to the 3rd plus 2x squared minus 8x minus 2x squared minus 4x minus 16, not minus 6, plus 16. And then if I combine like terms, I get x to the 3rd. Oh, look at this, guys. This is where I messed up. Hold on, hold on. Did y'all catch it before you paused the video? I hope you did. Because I missed these right here. This should have been a 4 and this should have been a 2. Okay, if you need to, repause. Sorry about that. Hopefully y'all caught it and y'all were like, look, she made a mistake. Excellent. I love when y'all catch that. Okay, here we go. Let's try it again. X to the 5th plus 2x to the 3rd minus 8x minus 2x to the 4th plus 4x squared plus 16. Okay, and then we put them in answer. Remember, we start with the highest one and we put them in descending order. So x to the 5th minus 2x to the 4th plus 2x to the 3rd plus 4x squared minus 8x plus 16. So this is the function. These are the factors. These are the x-intercepts. Okay, hopefully we are all good with that. Okay, the next lesson, 6.2.3. So we start into graphing, and there's a lot of information. I want to make sure you go ahead and read his video. Watch his video. But the main thing when we're graphing, there's two kinds of behaviors. So when we graph a linear function, there's two things we talk about. We talk about the y-intercept and we talk about the slope. Because if I give you those two pieces of information, you can kind of fill in the rest. So if I said the y-intercept is -4 and the slope is 1, you would have a pretty good idea of what that looks like in your head. So that's why we give it. That's why we have those two pieces of information. There are two pieces of identifying information. So with a polynomial, we have end behavior and behavior at the root. Okay, so I'm going to just draw a sample. And I'm going to talk about each of these things. I'm going to pretend that touches there. Okay, so the end behavior is really what it says. What is happening at the two ends? Okay, and we write it a kind of weird way that can be confusing, but like for the end behavior for this particular function. Okay, so first of all, it touches 4 times, but different behaviors happen at each x-intercept. But let's start with the end behavior. So as x approaches -infinity, okay, that's this end, meaning as x approaches negative, as x goes to the left, then f of x, or r of x, or p of x, or whatever, approaches, in this case, -infinity. So as x goes down, y goes down. That's basically what this is saying. Then over here, as x approaches positive infinity, f of x also approaches positive infinity. Okay, so we're going to talk about all the options here in a second. I'm going to give you a table. But basically, end behavior is just what is happening at the two ends, and we write it like this. So as x approaches negative infinity and as x approaches positive infinity, basically what is y doing? So that's what you're answering. If x is going down, what's y doing? If x is going up, what's y doing? Okay, that is end behavior. Then there's also behavior at the root. And Edward Berger doesn't really talk about this, so I'm just going to address it just a little bit. If it just goes straight through, then we call those cross. They just cross over the x-axis. That would be, let's say this is -4, -2. This isn't really drawn to scale. This is a 1, and this is a 3. Okay, so that would be x plus 4 would be the factor. And it would have an exponent of 1 because it just crossed it. And this would be x plus 2, and it would have an exponent of 1 because it just crossed it. Now this we call a wiggle. Do you see how it looks different? It's like a cubic function. Wiggle's probably not the technical term. So this would be x minus 1 to the third because it has this behavior. It doesn't just go straight through, it wiggles. And then this one, what does this look like right here? Should look like a quadratic. So this would be x minus 3 squared. Okay, so at the behavior at the root, it can cross, it can wiggle, or have a cubic-like look, or it can just touch it and look like a quadratic. So we have end behavior and we have behavior at the root. So let's talk more about end behavior, because end behavior is determined by two things. End behavior is determined by whether or not the leading coefficient is positive or negative, and whether or not it's an odd or an even function. So we're going to draw a table. Okay, so if the leading coefficient, actually we're going to do this. If it's an odd function and an even function, and then over here we have a positive leading coefficient and a negative. Okay, so an odd function would be something like x to the 5th plus blah, 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 blah. An even function would be x to the 4th, blah, 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 blah. Okay, then an odd with a negative coefficient is going to be something like -2x to the 5th. And on, and then this would be something like -2x to the 4th, and so on, so on. So the end behavior for an odd positive is basically going to look like a line. It basically follows a line, because think of a linear function. Linear is odd, right? So it would be as x approaches negative infinity, f of x approaches negative infinity, because it's going to go down and up. And this is, like I said, just the ends. We don't really know what's happening in the middle. Let's put this in here. And as x approaches, as x approaches infinity, f of x approaches infinity. So this is saying that as x goes down, y goes down, and as x goes up, y goes up. And these basically follow the same rules as a line, and these basically follow the same rules as a quadratic. Okay, so what would a quadratic be? Up and up. So as x approaches negative infinity, f of x approaches infinity. Man, why? I'm having a hard time. Sorry, guys. These should be these little arrows. Okay, and as x approaches infinity, f of x approaches infinity, because this one, as x gets smaller, y gets bigger. As x gets bigger, y gets bigger. Y is going up both times. So this is, the y is always going to be positive because it's always going up. Okay, and just to clarify, this section right here never changes. This little piece, it's the only thing that's changing each time is filling in this last blank. So the piece that's changing each time is just filling in this. Okay, so then if it's an odd function and it's negative, so this would be like a negative line, it starts up and goes down. So as x approaches negative infinity, f of x approaches infinity. So as x gets smaller, y gets bigger. As x approaches infinity, f of x approaches negative infinity. So once again, the piece that we're changing is just this little piece right here. And this says as x gets bigger, as x gets smaller, y gets bigger. As x gets bigger, y gets smaller. Okay, once again, think of a line. And then last one, think of a negative quadratic. Okay, a negative quadratic faces down. So as x approaches negative infinity, f of x approaches negative infinity. As x approaches infinity, f of x approaches negative infinity, because the y is going down both places. Okay, so this is kind of a lot. It's a totally new concept, the concept of end behavior. I actually wish we started talking about it earlier so that when we got here, it would be easy to understand. But end behavior is super important for graphing polynomial functions. It's one of the ways we describe what's going on, because so much is happening in the middle of a polynomial function. There's all the wiggles and all the stuff. So end behavior just gives us a really good picture of what that looks like, what a function can look like. So he's going to give you several, and you're going to give the end behavior. And like I said, remember that this first part never changes. So this whole section right here never changes. Basically, those pieces are just if x is getting smaller, what's happening to y, and if x is getting bigger, what's happening to y. Okay, and the leading coefficient is just the number out in front. So then I could give you a question and say, let's do this. Okay, so if I draw a little function, just by looking at this, can you tell me whether or not the coefficient is positive or negative? Great, it's going to be a positive coefficient. I'm sorry, negative coefficient, because it's going down. So think of it like a quadratic. They're both going down, negative coefficient. Is it going to be an odd or an even function? It's going to be an even function because they're both doing the same thing. They're both going down. So this would be something like negative x squared, negative x to the fourth, negative x to the sixth. We don't know all exactly what's happening. We could figure it out though, because this is a cross, this is a cross, this is a touch. Let me show you how we'd figure it out. I can't give all the information because I don't know what all the numbers are, but if I said this is 2 and this is 1 and this is 3. So this would be x plus 2. This would be x minus 1 squared because it just touches. Remember, that makes it a squared. And this would be x minus 3. So 1, 2, 3, 4. I know that this is going to be negative x to the fourth and then on and on and on. So I know that much information just by looking at this picture. Okay. So ask each other questions if you have them. Go back and make sure you watch those videos, and make sure you have a basic understanding of end behavior. End behavior even becomes more important in pre-cal and calculus. So there's a lot of end behavior type conversations that you're going to have later. Okay, next one. 6.2.4, I think we're on. Okay, this one is going to be about translating. And we have done so much transformation, translating, rotating, dilating. With all the other functions, you're going to now just do it with polynomial functions. So it's the same basic ideas of moving a function left, moving it right, moving it up, moving it down. Okay, so he is going to give you a like a basic function and ask you to translate it, move it up, move it down, move it left, move it right. So just an example. I'm just going to do number 1. So we have this function f of x equals x to the 4th minus 8. Okay, so this is what kind of function? Polynomial functions, x to the 4th. We can already have some information. It's even. Its leading coefficient is positive, and it's an even function because it's x to the 4th. So leading coefficient's positive, it's x to the 4th, so I know the end behavior is going to be up and up, right? So that's just a little, now that we have this little table, that's a little bonus information. And number 1 says that we're going to take this function, so we're going to have a new function, g of x equals f of x plus 4. So we're going to take our function, x to the 4th minus 8, and we're going to add 4, which gives us x to the 4th minus 4. So if this was, it was down 8, now it's down 4 because we moved it, we added 4 to it. So you can graph it on your calculator if you would like to help you with your sketch. So your original graph would be something like this, and this would be a -8, and your new graph would be like this, and this would be a -4. So that's just what we're doing here. So use your calculator to help you. You're just doing the, is it moving left? Is it moving right? Is it, like you might have one that dilates, it has more amplitude. Sorry, this would still cross in the same place. So when it dilates, it keeps the same x-intercepts. It just goes up and down. So that is 6.2.4, all about dilating, transformating. Okay, last section, and then there is a subchapter, so y'all might have some time to work on it. So the last subchapter, the last section is 6.2.5, and it is on curve fitting. Anytime we see curve fitting, think of the stat function of your calculator. So basically, we're going to give you data, and you need to come up with a function. That's what curve fitting is. Here's some data. Now, fit it to a model. Fit it to an equation of some type. Okay? So there is some different ways we can do this. One of them is with our calculator. But if you don't know what it is you're fitting, then the calculator is not as helpful. You can graph it and see if you see a picture. Like if I give you a graph and all the dots looked like this, well, you could say, okay, that's probably a quadratic. If all the dots looked like this, you could say, oh, that's a linear. If the dots look like this, you would say, oh, that's a cubic. But sometimes you can't tell. So the other thing we look at is we look at common differences in the y values. So you look at the y values and find the differences. So we're going to do a few problems together. So this is number 1, and I'm going to write the table. -2, -1, 0, 1, 2, 3, 22, 16, 10, 4, -2, -8. Okay, so you look over here and you see what's the difference. Well, 22 minus 16 is 6. Well, -6 because I'm subtracting this one from this one. 10 minus 16, -6. 4 minus 10, -6. What are we seeing here? -2 minus 4, -6. -8 minus -2, -6. So we have a common difference here of -6. So if it's the first difference is already common, then this would be linear. Okay, now if the first one isn't common, we keep subtracting, okay, until we find a common difference. Common difference. Okay, so what do you think happens if it's the second one? Well, then it would be quadratic. If it was the third difference, it would be a cubic. If it's the fourth difference, it would be a quartic. So let's look at another one. Okay, this is number 2 on your homework. Okay, at some point, this cut out. It stopped recording. Did it record this? Did y'all get all of this? I hate when it does that. It stopped recording. I don't know where. So I'm going to leave this here for a second. We talked about stat edit. Hopefully you got all of that. So then I was saying next week we're going to finish up polynomial chapter 6. We're going to review it all and do the practice test. And I will be there live in person with my happy face. So if you have any questions or there's any things you're not sure of, next week we can clear them all up before you do the chapter 6 test. Okay, so you have one more week before the test. So make sure you watch Edward Berger. Make sure you are ready to go for our last week on chapter 6. Okay, I'm scared y'all didn't get this. So I'm going to repeat it. If you did get it, then just y'all can stop. You don't have to watch this. If not, I'm going to repeat it because I'm worried that it didn't record. And I don't know why it does that. If you did get it, y'all can do the subchapter together. So if whoever is teaching or whoever adult in the room, if y'all would find the subchapter, it's like 6.2 subchapter, and put it on the board, and y'all can work together and do some of the problems. Like do a problem, I'll discuss it, see if you get the right answer, move on. And just to get y'all started on the subchapter. So, or whichever lesson from today y'all want to practice, find a problem from that lesson. So whichever lesson maybe was the hardest or that you have the most questions on, find one of those, and as a group work together with one another. So I just wanted to make sure y'all understood that you can do this in your calculator, L1, L2, stat edit, and then I asked y'all if it was linreg, which number is it? Is it stat edit? 4 is linreg, 5 is quadreg. I don't know which one is cube reg. Okay, it might be 6, it might be 8, it might be 7, but one of them is cube reg. So now I don't know if hopefully y'all got all of that. So once again, when you're done with this, do subchapter, pick a few problems, maybe go back to one of the sections that y'all think is the hardest, do it together as a class, discuss your answer, and I will be there next week ready to see y'all. Bye guys, have a good day.